Okay, this is my pre-calculus with my sine cosine lab number 2, and this is our last word problem. And this video is just for number 11. It says, in a tidal river, the time between the high tide and the low tide is 6.2 hours. At high tide, the depth of the water is 17.2 feet, while at low tide, the depth is 5.6 feet. Assume the water depth is a trigonometric function of time. It says graph the depth of the water over time if there's a high tide at 12 noon. That's important. That's going to be when time is 0. Label your graph indicated high and low tide, and then write an equation. A boat requiring a depth of 8 feet to sail is docked, that should be a D, is docked at 12 noon. That's when time is 0. What is the latest time in the afternoon it can set sail? So we'll talk about that in a minute. Let's graph this first, and then we'll find the equation. So the first thing I'm going to do is kind of set this up. So we're graphing this. This is the A part. I'm going to make it a nice big graph. And this is time in hours. Nice sketch here. And this is the depth. Let's go up a little bit. This is my depth in feet. Okay. So again, this is my graph. So this is going to be my 5.6 feet. Here's going to be my 17.2 feet. And I'm going to have time is 0 to be the 12 o'clock noon. Now, this is an actual time, okay? And that's going to be a little bit different than what else we're putting there. So we're just going to say at noon, the boat is docked. It said 6.2 hours later, so this is going to be 6.2 hours later. It's at low tide, and then 6.2 hours after that, which is 12.4 hours. That's when it's high tide again. All right, so we're going to convert these in a minute so that you'll know exactly what I'm talking about. But first, I'm going to use blue for water. Here's a high tide, low tide, high tide. And then I'm going to graph my graph. And there we go. So now we're going to find what could be a trigonometric formula for this. So I'm going to leave a little bit space. And we're going to do looks like. So this is for the B part. Looks like. And then I'm going to set it up, amplitude, frequency, period, and midline. Okay, so it looks like, because it's starting high, it looks like a nice cosine curve. So I'm going to put this here. The midline is going to be the high plus the low divided by 2. So the high plus the low divided by 2. So that's going to be y equals 11.4. And that's going to be our average water depth. So I'm going to use green here. So right here is going to be my midline, which is y equals 11.4 feet. Okay. Now my amplitude is either high minus my midline or midline minus my low. I'm going to use the high. It's an equal sign. 17.2, my high minus my midline. And I'm going to get 5.8. Okay. Now the period is a little bit different because I've got to look at my graph here, and it shows that it takes 12.4 hours for this to happen. So my period is 12.4 hours, which equals 2 pi over my frequency. So I got to figure out what my frequency is. So I'm going to kind of bring this over here to do this part for the frequency because it's a little bit different than what we've done. So if I cross multiply, I get 12.4f equals 2 pi, and then I divide by 12.4. My frequency is 2 pi over 12.4. Well, that looks a little weird for me to put my formula, so I actually put 2 divided by 12.4 and switch that to a fraction, and it came out to be 5 over 31, so it's going to be 5 pi over 31, or 5 over 31 pi. So that's going to be my frequency, okay? So now, I'll go back to blue. The depth of my water is going to be 5.8 cosine. Then my frequency comes next, which is 5 pi over 31, or you can say 5 over 31 pi. The time is in hours, that's my variable, plus 11.4. So now we have a nice representation of what is going on here. Now, the one thing that as we do this is I just want you to know what times we're talking. So I'm going to come up here and kind of convert this to a time because we have a time here as of 12 noon. So I'd like to know what that really is. So I know it's 6 something, and I know that's midnight something, but it's 0.2. So that's 0.2 of an hour. So if I over here on the side did 0.2, what does that equal out of 60 minutes? So I can figure out what am I talking about when I do that. When I cross multiply, I get 1.2, okay? So, excuse me, 0.12, 0.12. So that actually stands for 12 minutes. So this is actually 6:12 p.m. because 2/10 of an hour is actually 12 minutes. And then when I do it for this, you'll have to trust me, this is midnight. And when I converted 0.4, I got it to be 12, and it was 24 minutes. So it's 12:24 p.m. Okay, so these are all PM, but I just wanted to show you that's really what that is in time. Okay, so you can do this to any of them, is you can take whatever the decimal is, say what does that represent out of 60 minutes, and you can figure out, okay, that's what it tells you what part of the hour we're talking about. Okay, all right, and this isn't 0.12, it's just 12. This represents 12 minutes out of 60 minutes. Okay. So you can do this every single time, every single time. All right, so now let's go down here. So we have this, we know the actual times. So the low tide's at 6:12, and then the high tide again is at 12:24. Actually, this is going to be AM because this is at midnight. So this is like in the morning. So that's going to be in the morning. All right, so there's two things I did. This is 12 minutes. That's where that came from. And then this is 12:24 in the morning. Okay, so why am I doing that, you're asking? Why does it matter? Well, because it matters for this last part. This last part says, if a boat requires 8 feet to sail and it's docked at 12 noon, what's the latest time in the afternoon it can set sail? So the latest time it can go is, we need to find what that's going to be. So I'm going to put this equal to 8 feet, the depth. And when I do that, you're going to hopefully be able to figure out the time. So I got 5.8 cosine 5/31 pi t plus 11.4. So the first thing I'm going to do to solve that is subtract 11.4 on both sides. So I get negative 3.4 equals 5.8 cosine 5/31 pi t. And then I can divide both sides by 5.8. And when I do, I get this beautiful decimal. And I kind of wrote it all down because I really hate to round to the very last bit. So this is dividing both sides by 5.8. Okay. Now, in order to solve for time, I have to use the inverse cosine to actually get that out of those parentheses. Thanks for playing. So I have basically inverse cosine of negative 0.586207 equals 5/31 pi t. And then I'm going to go through and solve for t. So t is going to be, and I can just multiply as 31 over pi, and you can write it like this, 31 over 5 pi times inverse cosine of negative 0.586207. Okay, and when I do, I get, and this is why I showed this to you before, 4.336. So I actually rounded this, okay? I actually didn't round it because I wanted to be very specific. So I know it's after 4 p.m., all right? So I took the 33.06, 3.615, said, okay, how x out of 60, what does that come out to be? So I said, okay, what is this as part of an hour? Okay, so if you multiply that by 60 minutes to see what time we're talking, and it comes about 20 minutes. So x comes out to be 20 minutes. So you're really talking at 4:20. Okay, that's what that stands for. So here at 8 feet, so let's look at our graph. This is 11.4. So here's 8 feet. They have to have it that much to go. So basically, according to my sketch, at 4:20 p.m. is the latest they can leave, okay? Because they need 8 feet to set sail in the afternoon. Because if they go after that, then they're going to be stuck there because it's going to be lower than 8 feet. Well, now I want to figure out, okay, when can they come back? When's the earliest they can come back? So say they take some people out at 4:20 p.m. and they're out for a ride, and now they want to come back. When would that be? So how would I do that? Well, what you're going to do is you're going to take the end of that, which is going to be basically 12.4. So when can the boat return is my question. So I'm going to do the 12.4 because that's the end of that, the many hours. I'm going to subtract the 4.33615 I got, and I got 8.06. And when I converted the 6 minutes, it came out to 4 minutes. So it's really 8:04 p.m. is the earliest they could come back. That's when they can return. So this part right here is they can come back at 8:04 p.m. is the earliest they can return because they need to have enough water to dock. So this is kind of an interesting problem. I think I spent more time actually showing you how to do this, but to me, 12.4 hours and 6.2 hours is nice to know, but it's better to know the time as what we're talking about. So I hope this helps, and I'll see you in class.